right now, and while I'm walking around and checking off your simplifying radicals worksheet, you're just going to take a few quick moments to respond to those 4 questions. Hopefully they go well. If they don't go so well, we'll take some time to go over them in pretty good detail. That way you're ready for what we have to study today. Okay. As I look around, you guys did a nice job. You really did. This group is doing swimmingly well. I just wanted to take a moment to show you your correct responses, but these looked pretty good as I walked around, like I said. Number 1, just to be clear, should be 10 root 2. Number 2 should be 4 root 6. Number 3, also 4 root 6. And number 4, you have x to the first, y to the third, times the 4th root of x squared. Don't forget to include your index in your answer. That's a mistake I'm seeing a couple of times today. What I mean by index, what do I mean by that? Do you know, Jonathan? Yeah, it's a little 4 there. If you forget it, it's like you're telling me that there still is one, but it's 2, and that's not right. The index in your answer has to match the original index of the problem. So you want to keep that in mind as you're finishing up these particular problems. All right, are there any questions about the warm-up? Things that I would need to clarify for you? Okay, so to start today's lesson, I want you to put your pencil down for just a moment. I am going to, write something in the smartboard that I don't need you to write down. It's a trap, booby trap. Run for your lives. Okay, so what I mean by this, I'm going to write some stuff on the board. I'm going to ask my very smart period 6 college algebra class some very easy questions. Very easy questions. What I need you to do is shout out the answers. You don't have to shout, you can just say. But I do need you to take a moment to verbally respond, each and every one of you, verbally respond to the math problems I put up on the smartboard. Are you ready to do this? Okay. All right, so with that, my very first, very easy math question for you to evaluate is this. I need to know what 2 plus 3 is. Oh, yay, it is 5. Very good. D1 college algebra. All right, so yeah, 2 plus 3 is 5. Next up, are you ready? 2x plus 3x. Oh, very good. You all said 5x. That's nice. Not 5x squared. You didn't do anything with the x. You just left it 5x. Nicely done. Let's do something kind of similar. Let's do like 2a plus 3a. What's that? Do you see it? You see it? Yeah. So I didn't change the a. Like it all. Okay. Does anybody know what this is called, what we're doing right now? 3 words. Combining like terms. Yes, John. It is called combining like terms. You're allowed to combine like terms as long as what's true. Do you know? Something with a variable. Yeah, same base. Yeah, same exponent. The exact same variable part is actually the definition for like terms. So 2a and 3a are what we call like terms because they both have a attached to them. Okay, one more time just for emphasis. I want to do 2b plus 3b. What is that? 5b. Well done. Okay, so I can tell right now in just asking you these few simple questions that you are all very good at combining like terms. Today we have to apply this to radicals. So I'm going to do this one last time, but I'm going to change x, a, and b to be something else. I want you to talk to me about what you think the sum of 2 square roots of 5 plus 3 square roots of 5 should be. 5 square roots of 5. Very good. Do you see how they're kind of connected? We combine like radicals like we combine like terms. Now, here's how this is also kind of interesting, just to add a little bit to it. Do you know, without touching a calculator, don't you touch it, Do you know, without touching a calculator, what the square root of 5 is to say, like, 10 decimal places? Whoa, Ben's going for it. 10 decimal places, accurately. That's too close to 9. No, I don't know it. Come on. Yeah, just do square roots over and over again. It's a little deeper than that. But I'll go ahead and let you know that the square root of 5, you don't know what it is. You don't. I don't. We can fess up about that. I don't know what it is out to 10 decimal places. So it behaves a lot like a variable, something else you don't know in math class. So the square root of 5 behaves like x, behaves like a, behaves like b. It behaves like a variable in your mind. And this is the idea that allows us to develop the phrase combine like radicals. So that's our lesson for today. If you understand how 2 square roots of 5 plus 3 square roots of 5 comes out to be 5 square roots of 5, that is our lesson for today. We're just going to add a little bit more to it. Everybody okay with this? All right, so let's do a couple more, shall we? Make them a little bit tougher. We're going to go back into our notes. And right now we are looking at example 1. And there's a little fill in the blank at the top of it. Our radical expressions can be combined, in other words, added or subtracted, when they're like, or like radicals. In other words, they must have the exact same radical part. So we have one that's really similar to the, examples that I was just kind of drawing out for you on the marker board. 3 square roots of 2 plus 2 square roots of 2. Ideas on that? Yeah, very good. 5 square roots of 2. Square root of 2, again, behaves a lot like x. We might not know exactly what that value is. So adding 3 root 2 to 2 root 2 is a lot like adding 3x to 2x. You'd get 5x. But in this case, it's 5 square roots of 2. Now, let's say you're still not completely sold on the idea of this whole combining like radicals. Well, let me just spin it to you in a different way to maybe clarify the issue. If you take a look at 3 root 2 plus 2 root 2, you could actually factor that expression. What I'm trying to tell you is this. It's simpler than it looks. They have something in common. We could actually use the Gcf method on that very same problem. Do you see what the two have in common? Those two terms? Yeah, they have the square root of 2 in common. Very good, Chris. So what we can actually do, and I'm only making you do it just this one time to clarify. See how these have the square root of 2 in common? We could actually factor that square root of 2 out of the problem using our Gcf method. You bring down your plus, and then the square root of 2 times what gives you 3 square roots of 2? That would be 3. The square root of 2 times what gets you back to 2 square roots of 2? That would be 2. Simplifying what's in the parentheses right there, you have the square root of 2 times 5. That's the same as 5 root 2. Do you see how they match? So it's actually an option that you have. You could factor out a GCF and simplify the remaining parentheses to find the coefficient of your radical, or you could just combine like radicals. I think combining like radicals is easier, but to each his own. Part B. There we have 5 cube roots of 3 minus, and this is like there's a 1 in front of here, minus 1 cube root of 3. What do you think, Chris? 4 cube roots of 3. Very good. Did you just combine like radicals? Very good. Okay, part C. Our lesson today is about combining like radicals. So as it stands right now, can I subtract 4 root 2 minus the square root of 18? What do you think, John? No. No, I cannot. That's annoying. But I do have an option. What do you think, Rick? For part C, eventually, yes. You could take the square root of 2 out. That's interesting. I'm I'm trying to decide if I want to entertain it now or just put it on hold for a second. I'm going to have you put it on hold for a second. Yes, you could take the square root of 2 out, Rick. What's up, John? Do you know what to do? Okay, tell me about it. Yeah. You're right. Yeah. So, Rick, back to you, bud. Would you have taken the square root of 2 out right away? You can, and then the square root of 9 would be left over. So that would be 3. And then you would add together what's in the parentheses there. Make sense? Okay. So yeah, you could do that. You get the same answer either way. So this kind of gives us now what we see as a two-step process, if you think about it. We have 4 root 2, now minus 3 root 2. And we got that by simplifying the radicals first. So that's kind of step 1 if you're a person who likes step-by-step-by-step directions. Step 1, you're going to want to simplify the radicals in the problem first, and then in the last step, combine like radicals. Or if you're like Rick, he does the Gcf method, it sounds like. So 4 root 2 minus 3 root 2 is just 1 root 2, or we typically write that as the square root of 2. So what comes out of this problem now is a two-step approach to simplifying radical expressions. So in part B, I have 2 cube roots of 5 plus 2 cube roots of 40. You can simplify the cube root of 40. True story, you can. So I'm going to execute my two-step approach. I'm going to simplify the radical expression first. So I have to simplify the cube root of 40. How do you do that? Do you know, Chris? Yeah, very good. You break it down into 8 times 5. 8 is the perfect cube factor that goes into 40. I know that catches some of you off guard. You're probably thinking 4 was the number that would go down there. 4 is the perfect square that goes into 40. The index of these radicals is 3. So we had to find out of those 5 numbers I made you memorize a couple days ago, which of those 5 perfect cubes divides evenly into 40, and the answer to that is 8. So now we can bring down our little 2 there and cube root each piece. And again, I'm just executing step 1, which has me simplifying my radicals first. 2 cube roots of 5 out in front there. That's already done. And then I just need to simplify this sort of right side here. The cube root of 8 is indeed 2. So that turned into a 2 right there. Bring down my cube root of 5. So what I'm actually combining is 2 cube roots of 5 plus 4 cube roots of 5. So these are all equal to each other. 2 cube roots of 5 plus 4 cube roots of 5. I don't know what the cube root of 5 is. It behaves like x in my brain. It's like putting 2x and 4x together. 2x and 4x is 6x. So this is going to be 6 cube roots of 5. Questions about that? Okay, so now you get to try 2 of them on your own. I want you to try these real quick for me, and we'll make sure you can get those right. I'm going to do 1 problem from your homework for you, and then I'm going to cut you loose to try those 36 problems on your own. I see some of you are kind of jotting down a couple of answers already. Please understand, I'd like this 1 to 36 to be done on notebook paper. 1 to 36. Some of them don't require any work. Like if you look at number 1, that's kind of a no-brainer. But some of them actually do require some work, so please do this assignment on notebook paper. If you've started it already, you can leave it. Just pick up where you left off now. From this point forward, please on notebook paper. And in practice, the first one is 9 square roots of 2, and the second one is 9 cube roots of 2. We're going to do number 3 from your homework together. So number 3 on your homework tonight. Let's talk about that. The problem reads 4 square roots of 2 times 2 plus 2 cube roots of 3. So you're going to see why we need notebook paper every once in a while to do our problems. This problem requires a little bit of work. You can do your homework out of order. If you want to start with number 3, that's fine. I'll find it. But if you take a look, you have 4 square roots of 2 times the quantity of 2 plus 2 square roots of 3. So we have to simplify this. There's a little bit of a step that comes before simplifying our radicals. And that step in this case is the distributive property. And I saw several of you setting this up just great. You would take 4 square roots of 2, distribute it to the 2, and then 4 square roots of 2, distribute that to 2 square roots of 3. Here's how that looks. You take 4 square roots of 2, and you're going to multiply that by 2, bring down your plus, and then you have to take 4 square roots of 2, and then distribute that to 2 square roots of 3. Please keep in mind that multiplication is both commutative and associative. So you could rearrange these products based on how you would like to take care of the multiplication. You don't have to show this step, but here's what I'm doing in my head. Right now, as far as this particular expression is concerned, I'm going to multiply 4 times 2 and then worry about the square root of 2. 4 times 2, that's just 8. So that is 8 square roots of 2. Bring down my plus. And then again, because multiplication is both commutative and associative, you can rearrange that multiplication as it meets your needs. I would multiply the 4 times the 2 and then worry about multiplying the radicals together. So this second term actually reduces down to, or rather simplifies, to be the product of 4 and 2, which is 8. You don't necessarily need those parentheses there any longer. So 4 times 2 is 8. And then the square root of 2 times the square root of 3, based on what we learned with regard to the product property, is just the square root of 6. So I have 8 square roots of 2 plus 8 square roots of 6. Can I combine these? No. Why not? Do you know, Chris? Well, I can't simplify the square root of 6. That's very good. That's a good point. Why else can't I combine these right now? Hi, John. Yeah, the radical parts are not the same. In your head right now, the square root of 2, if you're thinking about it, here's you thinking, the square root of 2 might behave a lot like x. So that term might be hanging out there like 8x. But the square root of 6, that's a different number altogether. That's like 8y. You can't combine 8x and 8y, so you can't combine 8 root 2 and 8 root 6. This is your answer. You're all done. They don't have the same radical parts, so you can't combine them. You're only allowed to combine like radicals, is the moral of today's story. Okay, questions about that? Okay, so you can keep working on those problems. You do have 1 to 36 total for tonight.